Hey, Algebra 2, Lesson 36. We are overcoming a third obstacle in factoring and polynomials. What if there are no real number solutions? Okay, that's our third obstacle in factoring. Okay, first we're going to do a little bit of review. We are going to find all solutions to each of the systems of equations below by using any method. I prefer algebraic. You can also go graphically, but I just like the algebraic method. So let's go ahead and try these. First of all, let's see. If I multiply this top one by 3 and the bottom one by -2, I'll get this. 6x -12y equals -3. -6x plus 12y equals -8. And then I add them. Those cancel. Oh, why did I write 16? -2 times 6 is 12. Sorry. I think I said 12. Those cancel. I'm left with 0 equals -11. Yeah, that's not true. If we graphed these, let's see, this first one would be, put it really quickly into slope-intercept form. I'd have y equals -2 over 4 x. Nope, that'd be positive 2 over 4x. Plus 1/4. And then the bottom one would be y equals 3 over 6 x. Let's see if I'm doing that right. Yep. Plus 4/3. So really we have here is equal slopes. So one's going to cross the x-axis at 1/4 and one at 4/3. So those are really awesome lines, aren't they? They're beautiful lines. We have parallel lines, so there's no solution when you have parallel lines, correct? Let's try this next one. I'm going to go ahead and substitute and just set those equal to each other. They're both set equal to y, so I can go ahead and set them equal to each other. If I move everything to the left side, x squared minus 2x plus 3 equals 0. I can't factor that off the top of my head, so let's go ahead and use the quadratic formula. -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I get 2 plus or minus the square root of 4 minus 12. I have a negative answer. So another no solution. So that doesn't work. We had a no solution for the first one because they are parallel lines. The second one, if I graphed it, I would have a parabola. Oops. Parabola that crosses pretty far down, and then a line that crosses at -5. They don't cross each other, so there's no solution. Okay, this last one, I'm going to algebraically again. Actually, I'm going to subtract them. I'd get cancel, cancel, 0 equals -3. Another one. If I graph them, I have a circle at center origin, radius of 1, and a circle at center origin, radius of 4. They don't cross each other, therefore there's no solutions. Are there any real number solutions to the system y equals 4 and x squared plus y squared equals 2? Well, what do we see here? If I have x squared plus y squared equals 2, that is a circle with a center at the origin and a radius of the square root of 2. And this would be a line at y equals 4. 1, 2, 3, 4. That was awful. Let's see if I can do better. Not bad. Y equals 4, and a circle with a radius of the square root of 2. So are there any real number solutions? No. Solution graphically, if I look at it algebraically, let's go ahead and substitute it. X squared plus, let's see, y squared is 16 equals 2. Subtract 16 from both sides, I get negative 14. Square root of both sides. I don't have a real answer. Okay, I square roots of 14. So algebraically, I'd have no solution also. Can't find any real number solutions. This isn't real. Okay, square root of a negative number is not real. It's imaginary. Okay, does the line y equals x intersect the parabola y equals negative x squared? First I'm drawing my x and y axis a little bit thicker because this graph is pretty thick. Y equals negative x squared. Let me change my pen again. First let's do our line y equals x. Okay, not bad. I plotted a few points. When x equals 1, y equals 1. When x equals negative 1, when x equals 1, y equals negative 1. When x equals negative 1, y equals negative 1. Get that straight. Draw a really basic parabola. So does the line y equals x intersect the parabola y equals negative x squared? If so, how many times and where? Draw the graphs on the same set of axes. Okay, it crosses it in two places. If we see those two places right there. So yes, it does. If x equals 0, y equals negative x squared equals 0. And then if x equals negative 1, y equals negative x squared equals negative 1 also. So I've got 0, 0, and negative 1 are my two solutions to that problem. Does the line y equals negative x intersect the circle x squared plus y squared equals 1? Oops, I'm blue. Oh well. First, let's do y equals x. Sorry, y equals negative x. That means we're going to go up this way. Just honestly a little bit easier for me to draw because I'm left-handed. The y equals x1 was sort of hard for me to draw on this particular grid. So there we have y equals negative x, and then x squared plus y squared equals 1. My radius is 1, and my center is 0, 0. So those are my points. Let's see if I can, ooh, that was bad. See if I can draw a circle. Try one more time. It's about as good as it's going to get. So does it cross? If so, how many times and where? I've got one intersection right there and one intersection right there, right? Two intersections. So the line y equals negative x intersects the circle at two distinct points. It doesn't tell us how to solve it, but we can do that pretty easily. Let's go ahead and plug in negative x for x squared, or for y, so we have y equals negative x. Let's plug it into here. So I have x squared plus y equals negative x squared equals 1. So x squared plus x squared equals 1. 2x squared equals 1. X squared equals 1/2. equals, let's see, I think the square root of 2 over 2 is how I would rationalize that. We cannot forget plus and minus. So there's my x value. Now if I plug that back in to get y, I would have y equals negative x. Plug in positive. If I plugged in, these values right here, I would get, when I plugged in negative square root of 2 over 2, I'd get positive. And if I plugged in positive, I would get negative. So I have my two solutions. Okay, number 4. Does the line y equals 5 intersect the parabola y equals 4 minus x squared? Why or why not? Let's go ahead and try. I'm going to put this one, rearrange this one a little bit. Y equals negative x squared plus 4. So I'm going up 1, 2, 3, 4, and opening down. Hold on. Plotted a few points. If I plug in positive 1 for x, I would get 3 for y. And if I plugged in 2 for x, I would get 0 for y. And that's pretty good. And now the line y equals 5 is up here. So they actually don't intersect. We have no solution. Okay, no solution. They don't intersect. Okay, and we're done. We're to our lesson summary. An equation or a system of equations may have one or more solutions in the real numbers, or it may have no real number solution. We're going to get into this in the next 2 lessons. If there's no real number solution, what does that mean? We still have a solution, it's just not real. It's not a real number. 2 graphs that do not intersect in the coordinate plane correspond to a system of 2 equations without a real solution. If a system of 2 equations does not have a real solution, then the graphs of the 2 equations do not intersect in the coordinate plane. A quadratic equation in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a is not 0, that has no real solution, indicates that the graph of ax squared plus bx plus c does not intersect the x-axis. Okay, that's really important. If we have a quadratic equation that doesn't intersect the x-axis, that means it doesn't have any solutions. There's no zeros. Remember, when we have a quadratic equation that intersects the x-axis, then we have zeros, we have solutions. If it doesn't intersect the x-axis, then there's nowhere that I can say x equals something because it never crossed the line. Same with circles. If I get a circle that doesn't intersect the x-axis, then there's no solutions. There are no zeros. Okay. This last part of the slide is pretty important, so I hope you listened till the end. Otherwise, I'm sure we'll answer your questions tomorrow when you work on the problem set. Good job.